Hey everybody, welcome back to another video on the Mathematical Genius YouTube channel. In today's video, I will be going over scientific notation. This video is the 6th video in 7th grade math under the unit of number theory. Before we begin, I'm going to really quickly talk about which videos are coming up on this channel. So, in the next video, I will be talking about classifying numbers, and the final video for this unit, factorials. So let's get right into it. Finding the scientific notation is very easy to solve once you understand how to do it. Scientific notation is mainly used for incredibly small numbers such as 0.000035 or incredibly large numbers such as 45080000. We will start by converting huge numbers into scientific notation and do a few example problems. Then, we'll do extremely small numbers into scientific notation and also do a few example problems. Finally, I will give you guys a few individual problems. Anyway, let's get started with converting huge numbers into scientific notation. The very first thing you want to do is look at the very first digit, which isn't a 0. What I mean by this is, for example, look at 450000. The very first number, which isn't a 0, is 4. Basically, what we want to do is move the decimal to right before that and count how many times the decimal moved. This might sound a bit complicated at first, but hopefully, as we work on it more, you will understand it. After this step, we need to set the scientific notation up. Once we have moved the decimal place to where it should be, get rid of all of the zeros after the last non-zero integer. Next, set this to times 10 to the whatever number it was you counted. This may seem very complicated right now, and I'm sorry if it does, but hopefully now as we work on a few example problems, it will clear up a bit. So here is the first example problem. Find the scientific notation of 673,000,000. First, let's start by finding the first non-zero integer. That would be 6. Since the decimal place is at the very end of this number, right after the last 0, we need to move it to right before the 6. We move the decimal at the end of the number to right before the 6 8 times, so we need to remember that. The next step is to put the decimal after the 6 and get rid of all the zeros after the last non-zero integer. The last non-zero integer is 3, so we have to get rid of the 6 zeros that are after the 3. We would have 6.73. Next, we need to multiply 6.73 by 10 to the 8th power since we moved the decimal 8 times to get it before the 6. So, our final answer is 6.73 times 10 to the 8th. Now let's move on to the second example problem. Find the scientific notation of 5429,000,000. Let's start by finding the first non-zero integer. That would be 5. Next, we need to count how many times the decimal is moved from the end of the number to before the 5. This happens 9 times. Next, we need to put the decimal after the 5 and get rid of all the zeros after the last non-zero integer. The last non-zero integer is 9, so we can get rid of all the zeros after that. We would be left with 5.429. Finally, we need to multiply this by 10 to the 9th, since 9 was the number of times we moved the decimal. The final answer is 5.429 times 10 to the 9th. Since we have done a few example problems with finding the scientific notation of large numbers, let's move on to finding the scientific notation of small numbers. Converting super small numbers into scientific notation isn't much different than converting super large numbers into scientific notation. The first step you need to take to convert small numbers into scientific notation is to find the first non-zero integer in the number. For example, in 0.0000669, the first non-zero integer is 6. After this, we want to move the decimal place to right after the first non-zero integer. For example, we would move the decimal 5 times to get it after the 6. Then we need to move the decimal place to right after the first non-zero integer and get rid of all the zeros before that. For example, it would look like this, 6.69. After this, we need to multiply 6.69 by 10 to the negative fifth. We need to multiply it by negative 5 this time because we're making it smaller. When the integer is huge and you are converting it into scientific notation, the exponent to which you are raising the 10 to has to be positive. However, if you are converting a small number into scientific notation, the exponent that you are raising the 10 to has to be negative. Hopefully now you understand how to convert super small numbers into scientific notation, but if you don't, that's fine because I'll be doing 2 example problems. Here is the first example problem. Convert 0.00000325 into scientific notation. Let's start by finding the first non-zero integer. That would be 3. After this, we need to count how many times we move the decimal place to be after the 3. We do this 7 times. Next, we need to move the decimal to right after the 3 and get rid of all the zeros before the 3. We would have 3.25. We move the decimal 7 times, so we need to multiply 3.25 by 10 to the negative 7th. We would get 3.25 times 10 to the negative 7th. Here is the second and final example problem. Convert 0.000000094137 into scientific notation. We first start by moving the decimal to after the first non-zero integer. The first non-zero integer is 9, so we need to move the decimal to after the 9. The next step is to count how many times the decimal place is moved when we take the decimal place and put it after the 9. This happens 8 times. Next, we need to move the decimal and get rid of all the zeros up until the first non-zero integer. This would result in 9.4137. Finally, we need to multiply this by 10 to the negative 8th, since we are moving the decimal 8 times to be right after the 9. Our final answer is 9.4137 times 10 to the negative 8th, and we are done. Now that I've explained to you how to convert super small numbers or super large numbers into scientific notation, and also worked with you through a few example problems, here are 10 problems for you to work on. Please pause the video and work on them on your own, and in a second, I will show you the answers. So here are the answers. The answer to the first question is 6.4 times 10 to the 4th. The answer to the second question is 9.57 times 10 to the negative 4th. The answer to the third question is 4.45 times 10 to the 5th. The answer to the fourth problem is 7.76 times 10 to the negative 7th. The answer to the fifth problem is 8.83 times 10 to the 10th. The answer to the sixth problem is 9.46 times 10 to the negative 2nd. The answer to the seventh problem is 2.22 times 10 to the 6th. The answer to the eighth problem is 6.53 times 10 to the negative 6th. The answer to the ninth problem is 8.74 times 10 to the 8th. And the answer to the final problem is 1.23 times 10 to the negative 3rd. Thank you guys so much for watching this video. If you did enjoy it, make sure that you like and subscribe. If you have any questions regarding converting numbers into scientific notation, leave them in the comments below and I will respond to them. In the next video, I'll be talking about classifying numbers. That's it for this video, and I will see you guys next time.
Just see those sleigh bells jingling, ring, tingle-tingling. I'm on, it's lovely weather for a sleigh ride together with you.